So let's talk about supply and demand here. So previously, when we were thinking about our cost per items or number of items sold, we weren't really thinking about the effects of supply and demand. And our main idea here is that when the number of units produced or sold by a firm are small compared to the number sold by the industry, then we don't really need to worry about supply and demand that much, right? They're just sort of not having a big effect on the market, so we don't have to consider that. But in special situations where the number of units sold represents a large percentage of the number sold in the industry, then we can always sell more by lowering the price per unit. Right, so this is this idea of supply and demand, right? In particular, of demand. I can increase my demand by decreasing my price. So we want to think about how we can use these ideas in our mathematical models and what are some things that we want to know about them. So the first thing that we're going to look at is this idea of demand. So we know that generally as a price decreases, right, as our price is going down, then the demand should increase. More people are going to want to buy something if it costs less. Right, that's this idea of demand, where we want to think of demand as the number of items that can be sold. Here I'm going to assume that we have a linear demand model. So I'm going to have a straight line, and because as the price decreases, the demand increases, I should have a decreasing slope here, or a negative slope. So my demand equation should be going down. Now we want this to sort of be consistent with the cost and revenue and profit models we were talking about before. So we want the input, this axis down here, to be represented by X, which is the number of units sold. So maybe that's not the way you usually think about demand. Maybe you think about the input being the price and the output being the number of units sold. But for right now in this course, we want our number of units sold to be along that x-axis. And then we'll have that y-axis represent the P, the price per item. So when the number of units sold is really small, that's because the price was really high. If I have a lower price, lower price will give me a large number of items sold. So the higher the price, the less number of units sold. Since this is a negative slope, we also often want to think about this as some negative C x plus D. So I have this linear model with a negative slope. So it's important to remember that demand always has that negative slope. Now let's compare our supply model. So for supply, we know that, right, if I'm a company and I'm trying to decide how much of something I should make, if I'm not going to be able to sell it for a lot of money, I'm not going to really want to make that much of it. But if I can sell it for more, then I'm going to be able to get more profit, so that I'm going to want to produce more. So the company will produce more units, right? It's going to produce extra units if the price per item is really high. So here, the higher the price per item, the more units it's going to produce. So for my supply, I'm going to get this positive slope. Right? And that supply curve is telling me the price required, how much money I have to be able to sell something for, so that that company is willing to produce X items. So we can think of that as the interpretation of our supply curve. Now let's put these two together. When I want to look at my supply and my demand together. So remember, the one that has positive slope, that's going to be my supply. The one that has negative slope, that's going to be my demand. Right? As I have higher and higher prices, I'm going to demand less and less, but the companies are going to want to make more, so my supply gets bigger and bigger. So let's look at the different things that are going on in this graph, right? So for example, let's say the price per item is $5. So I can go over to my supply curve and let's go down here and see what's going to happen. Maybe this is 20. So if my item can sell for $5, companies are willing to produce about 20 of them. But if we go over to our demand curve, the demand is going to be more like 50. So people want 50 of them, but there's only 20 that have been produced. So then in that case, we end up with a shortage. We don't have enough to meet our demand. Now, if the price was $10 instead, if I go over here, both my supply and my demand are 40. So people want to buy 40 of them if they're $10. Companies are going to produce 40 of them if they're $10. So this point where the demand is equal to the supply, that's where we want to be. And that's called our equilibrium. And so once we have this equilibrium, we have both an equilibrium quantity, the amount that are going to be made and sold, and an equilibrium price, the price per item. So you find that equilibrium by setting your supply equal to your demand. Oops, I wrote quantity, I meant to write price. The X value is that equilibrium quantity. And if you plug that X back in to either the supply or the demand, that's your equilibrium price. If I put the price even higher, now my demand is more like 20. My supply, going all the way over, is going to be something like 60. So the companies have produced 60 of these, but there was only 20 that were bought. So this is the case where we end up with a surplus. So we definitely want to be in this condition probably where we have this equilibrium, where the supply is equal to the demand. I don't have a shortage, I don't have a surplus. But if the price is too high or the price is too low, I might end up with one of those. Let's look at one example here, finding that equilibrium price and quantity. So assume for some good, the demand is given by P equals negative X plus 6, and the supply is given by P equals X plus 3. So again, my demand has that negative slope, my supply has that positive slope. And to find the equilibrium, we just want to equal or set the demand equal to the supply. So I'll do that. I get negative 6 plus X equals X plus 3. We'll get the X's on one side, so I'll add this X over. I'll subtract that 3. So I get 3 is equal to 2X, or X is equal to 3 over 2. So that's going to be my equilibrium quantity, because it's the X. Maybe it's in something that's measured like pounds or tons, so that would actually make sense to have a half there. And then I can take that X value and either plug it into my demand equation. So I get P equals negative 3 halves plus 6. So 6 minus 1.5 is 4.5. Or alternatively, you could have plugged it into the supply equation. P equals 3 halves, 1.5 plus 3, which also gives us 4.5. And either way, we can get that that 4.5 gives us that equilibrium price. So I can find both the equilibrium quantity, 1.5 or 3 halves, and the equilibrium price, 450. Okay, in the next video, there'll be several examples. In particular, we'll see some examples of how we can get quadratic revenue models and then how we can find the mins and maxes of those.